So in this video, we're going to pick up with problem number 7 in our review for test 3. So in problem number 7, if a pair of running shoes costs $130 in 2014, what will they cost after 5 years of inflation if the inflation rate's 4.3%? So we have a pair of running shoes. This is problem number 7. We have a pair of running shoes that cost $130 in the year 2014. We want to know what they're going to cost 5 years later, which incidentally would be the year 2019, if the inflation rate is 4.3%. So what we're going to do here is we're going to use our formula, A equals P times 1 plus R raised to the T power, where R is our inflation rate. So this is basically the same as the compound interest formula, except we're looking at an annual rate, so we don't need the R over M part. So in this case, our P is the $130. So this is $130. And 1 plus our inflation rate, again, was 4.3%, which as a decimal is 0.043. So I'm going to write that as 0.043, and our time is 5 years. Now 1 plus 0.043 is 1.043, so I need to figure out what is 130 times 1.043 raised to the 5th power. So if I bring in my calculator, 130 times 1.043 raised to the 5th power, so that is $160.46 if we round. So 5 years later, if the inflation rate is 4.3%, the cost of the shoes will be $160.46. So that is the answer to number 7. Number 8. We want to find the future value of an account paying simple interest if P equals $1,500, R equals 9%, and T equals 2 years. So since we're talking about simple interest in this case, our simple interest formula is I equals P times R times T, the principal times the rate times the time. And so this is giving us the amount of interest. And so our principal is $1,500. Our interest rate is 9%. So we're going to write that in decimal form, 0.09, and our time is 2 years. So if we multiply 1,500 times 0.09 times 2, that is $270. So we're going to have $270 in interest, which means the future value 2 years from now is going to be the $1,500 plus the $270, so that would be $1,770. Now we could have also done that problem by using our future value formula. Our future value formula is that A equals the principal times 1 plus R times T. So we could have used this formula to get directly to here. So again, our principal is $1,500. So if we take that times 1 plus our rate, which is 0.09 times 2, and so if I take 0.09 times 2, that is 0.18, so this is 0.18, and 1 plus that will be 1.18. So this would be $1,500 times 1.18, because that's what I would get in parentheses. And if I take $1,500 times 1.18, that gives me the $1,770. So we could have done that using this direct formula, which gives us the future value, instead of doing it in 2 steps like we did here. Doesn't really matter which way, you can use either one. Problem number 9. You have agreed to pay off an $8,000 car loan with 24 monthly payments of $400 each. Use the simple interest formula to determine the interest rate that you are being charged. Let's look at that on a separate sheet of paper. So, problem 9, again, we know that we have an $8,000 car loan that we're going to pay off in 24 monthly payments of $400 each. So let's first of all figure out how much we actually paid back. So we actually paid 24 monthly payments of $400 each. So if I take $400 times 24, 400 times 24, we actually paid $9,600 for the car. After we've made all 24 payments, that's how much we paid. Now the cost of the car was $8,000. So that means our interest was the difference, $9,600 minus the $8,000 cost of the car. So that was $1,600 in interest. Now again, what we're supposed to figure out is we want to use the simple interest formula to determine the interest rate that we're being charged. So we paid $1,600 in interest. We want to know what the interest rate is. Well, the interest formula, remember, is principal times rate times time. So we know that we paid $1,600 in interest for an $8,000 car, so that's the principal, times the rate, and we made that in 24 monthly payments, so that is 2 years worth of time. So if I clean this up a little bit, that's $1,600 equals 8,000 times 2 is $16,000 times the rate. So if I divide both sides by $16,000, the interest rate, R, is going to equal 1,600 divided by 16,000, and that is 0.1. So 0.1, that's the decimal version, and that would be 10%. If I multiply by 100%, the decimal point moves 2 places to the right, and we get the percent symbol. So our interest rate is 10%. Let's take a look at question 10. Jacob wants to defer his income taxes of $11,400 for 6 months. If he must pay an 18% penalty compounded monthly to do this, what will his tax bill be? Well, we're compounding monthly, so that means we're going to need to use the compound interest formula. So A is going to equal P times 1 plus R over M raised to the n power. So we know that the tax bill that he is deferring is $11,400. So that's P. P equals the $11,400. We're going to do this for 6 months, so M is going to equal 12 because we have to be compounding how many times per year. So since we're talking about compounding monthly, that's going to be 12 months. So we're compounding monthly. We know that the interest rate is 18%, so as a decimal, that's 0.18. And we're doing this for 6 months, so our N is going to equal 12 times half a year. 6 months is half a year, which is going to be 6. So I'm just going to plug these values in this formula. So A is going to equal 11,400 times 1 plus 0.18, again, because it was an 18% interest rate, divided by 12 because we're compounding monthly, and we're raising that to the sixth power because we're only doing that for 6 months. So there's only going to be a total of 6 months. Now, if I take 0.18 divided by 12, that is 0.015. So this part right here is 0.015. If I add 1 to that, that is 1.015 that I have here in parentheses, raised to the sixth power, and this is dollars. So if I take 11,400 times 1.015 raised to the sixth power, that is $12,465.25 if I round to the nearest penny. So $12,465.25. So our question was, again, what will his tax bill be? So 6 months from now, his tax bill will be $12,465.25. So by waiting 6 months, his taxes have gone up by a little over $1,000. Well, his taxes didn't so much go up, but his penalty, he has to pay a pretty substantial penalty for that. Let's take a look at number 11. Palma wants to establish a fund for her granddaughter's college education. What lump sum must she deposit in an account that pays an annual interest rate of 6% compounded monthly if she wants to have $10,000 in 10 years? So she's going to put in a lump sum of money right now, and the question is, how much does that need to be if she's going to have $10,000 10 years from now? So again, in this problem, we're going to be using our compound interest formula. So A equals P times 1 plus R over M raised to the n power. Now our question is, what's the principal have to be if this is going to be $10,000 in 10 years? So our future value is $10,000. The interest rate was 6%, so R equals 6%, which as a decimal is 0.06. We're compounding monthly, so M equals 12. And we're going to do that for 10 years, so T equals 10 years. And so that means that N is going to equal 12 times 10, which is going to be 120. So we're going to compound interest. It's going to be calculated 120 different times. So if I fill these in, I need to solve for P. I need to know what's the present value if it's going to be worth $10,000 in 10 years. So $10,000 is going to equal what times 1 plus 0.06, that's R, divided by 12, raised to the 120th power. Well, 0.06 divided by 12 is 0.005. This is 0.005, and so 1 plus that is 1.005. So we have $10,000 equals P times 1.005 raised to the 120th power. If I bring my calculator back in, 1.005 raised to the 120th power is equal to 1.89396734. So I have $10,000 equals P times 1.819396,734. So P is going to equal what I get when I divide 10,000 by that. So 10,000 divided by 1.819396,734, and that is $5,496.33 if we round. So right now she would need to put in a lump sum of $5,496.33 in order for that to grow to be worth $10,000 in 10 years. Number 12. If you invest $1,000 in an account that pays an annual interest rate of 6.4% compounded monthly, how long will it take for your money to double? Well, number 12. So we're going to be putting $1,000 in an account that pays 6.4% compounded monthly. So again, we're using the compound interest formula. So A equals P times 1 plus R over M raised to the n power. And again, what we want to know is how long is it going to take our $1,000 to double. So right now we're investing $1,000 and the interest rate is 6.4% or 0.064. It's compounding monthly, so 12 equals M, and we want the amount to double, so the future values to be $2,000, and our question is, how long is that going to take? So we need to figure out what amount of time that's going to be. Well, if we know that N is equal to M times T, and M is 12, then N's going to equal 12T, and that'll give us the time in years. So we have $2,000 is equal to $1,000 times 1 plus 0.064 divided by 12 raised to the 12t power. So let's clean up this problem. So I have 2,000 equals 1,000 times. Now 0.064 divided by 12, that is 0.00533333 repeating. So this is 0.0053333, and the 3 just keeps repeating. If I add 1 to that, that's going to be 1.005333333, and the 3 just keeps repeating. So I need to solve for t. So we can divide both sides by $1,000. So that divides out, and I get 2 equals 1.0053333 repeating raised to the 12t power. Well, I need to get that variable down from being the exponent, so the way I do that is by taking the logarithm. So I'm going to take the log of 2, and that's going to equal the log of 1.0053333. I'm just carrying a bunch of 3's because I don't want rounding to cause a problem. Doing that, I can bring the 12t down. So the log of 2 equals 12t times the log of 1.005 and all the 3's repeating. So if I divide both sides by 12 and divide both sides by the log of 1.005333 repeating, t is going to equal the log of 2 divided by 12 times the log of 1.005 and then a bunch of 3's. So if I do that on my calculator, the log of 2 divided by parentheses 12 times the log of 1.005 and then a bunch of 3's, and that gives me 10.86 years. So that is about 10.86 years, which incidentally, if we multiply that by 12, that would be about 131 months. So we could say, or 131 months. Let's pick up with problem number 13 on the next video.